Hello, welcome to section 7.1, and this is kind of all of this module will be all of the geometry that we have left to do. So we're going to look at circles, we're going to look at surface area and volume and area of composite figures. Lots of stuff going on in this module, and we'll try and break it up for you as best we can. All right, the first part of this module is circles. And here's some vocabulary here. Now, most of this should sound very familiar to you from junior high. I've put the definition on here and then drawn the circles for you in case you don't have a geometer or a compass with you. So, just running through here, a circle is the set of all points equidistant from a fixed point called the center of the circle. So, the circle is actually this ring here. It's not this solid inside part. It's actually just this ring going around here. We'll identify the center of that circle with a point, and we'll label it. So that point is the center. And then when we name a circle, we name it by its center, and the symbol for a circle looks like that. And we would say that is circle A. Concentric circles are two or more different circles that share the same center. So if you look at this, we have two circles, kind of one inside of the other, almost like a dartboard. Circle, if I put the center there at B, then both circles have center B. Both of them could be named circle B. We'd have to say big circle B and little circle B, if you will. The next one, congruent circles. Two or more circles are congruent when their radii are congruent. So let's draw in, we'll call this circle A with a radius here, circle B, with another radius. Yes, I know I haven't officially defined radius yet. That's down here a couple ways, but you remember from junior high what a radius is. Goes from the center of the circle to the edge. If we mark those two radii to be congruent, then we can say circle A is congruent to circle B. A chord is a segment whose endpoints are on the circle. So segment here, and the endpoints of that segment are on the circle. So CD, or segment CD, is a chord. A secant line is a line that intersects the circle at 2 points. And you can think of a secant as the extension of a chord. So there's the chord, endpoints on the circle. If we take that and extend it into a line, then we have a secant. And we can just call that, not secant, secant, S-E-C-A-N-T, secant line E-F. All right, a tangent is a line that intersects a circle at exactly 1 point. And you can kind of think about it as it just skates right along the edge of that circle. It doesn't cross through the circle. There's a tangent line. And let me put a point on here, call it G. And then so we can name this line, I'll put another point down here, GH. So we have tangent line GH. The point where that line intersects the circle, that point right there is called the point of tangency. right, radius we alluded to a couple of minutes ago with congruent circles. And again, you remember this from junior high. A radius is a line segment with one endpoint at the center of the circle and the other endpoint on the circle. So here's the center. Let's call that I, and then connect to the edge of the circle. Call that a J. So the radius is IJ, segment IJ. Diameter is a chord, so endpoints on the circle that it has to pass through the center of the circle. There's your diameter. IJ, let's call this KL. And that diameter is segment KL. Now, relationship between these two guys, between the diameter and the radius. 2 times the radius equals the diameter. Equals 2 times a radius. Or you could say a radius equals half of the diameter. Here's a radius and another radius. Together they'll make the diameter. Okay, minor arc. It's an arc or part of the circle that is less than halfway around the circle. So it's part of the circle. And usually we use kind of a shaded portion to represent an arc. And that is arc MN. And the way we write that is with a curve over the top here, an arc. Be very careful that it is curved, that you don't just make it look like a segment bar. You must write that as curved. Minor arc is less than halfway around a circle. Major arc, more than halfway around the circle. Now, when you name a major arc, you must use 3 letters. So we'd have to say arc where it starts O, goes through P, stops at Q. So O, P, Q. There's the major arc. If you just said arc OQ, that would be the shortest distance between O and Q, which would be a minor arc. So major arcs must use 3 letters. A semicircle is exactly halfway around the circle. To show that it's exactly halfway around, usually we put in a diameter here. Now, semicircles you can name either way. You can name with 2 letters or 3 letters. It makes no difference. So you could say that semicircle are T, which could be the top half or the bottom half. Or if you want to specifically talk about this top half, you would have to name 3 letters, are ST. Most of the time for semicircles, either 2 or 3 letters is acceptable. A central angle is an angle whose vertex is at the center of the circle. Reminder here, if I am going too fast for you, please feel free to stop the video, pause, rewind, and catch it again. Central angle has its vertex at the center of the circle. Let's call this U, VW. Now when we name that angle, because there's only one vertex there, we could say angle V, or we could use the three-letter name, angle UVW, or we could reverse the order, angle WVU. Okay, central angle, inscribed angle. This is an angle whose vertex is actually on the circle. So vertex on the circle would be an angle that looks like this. X, Y, Z. And that inscribed angle, again, because there's only one angle with this vertex, we could say just angle Y. Or we could use the three-letter name XYZ, or angle ZYX. The last one, vocabulary word for this section, is intercepted arc. It's the portion of a circle that lies between two lines, rays, or segments that intersect the circle. So let's just draw a couple of lines here, or segments, however you want to think about them. Arrows, lines if you want to put arrows on the ends. Here's the center down here. If we talk about this arc right down here, that would be an intercepted arc for those two lines. We could also say this arc up here is an intercepted arc for those two lines. Or this arc over here is an intercepted arc. And there's one more. Any of those arcs could be intercepted arcs for those two lines, which is why we generally put letters on here to name those arcs specifically. All right, let's turn the page and we'll look at some examples using these vocabulary words. We have this diagram here. Name the center of the smaller circle. All right, we've got this big circle, or I'm sorry, little circle here, big circle out here. Center, smack dab in the middle of that smaller circle, is A. Center of the larger circle, also A. All right, now, since both the smaller and larger circles share the same center, what word from above, previous page, best describes the circles? So go back over here. Where do you see something that talks about one circle inside of the other one with the same center? Yes, those are concentric circles. All right, radius of the smaller circle. Smaller circle has to go from the center, so at A goes out to the edge of that smaller circle. Right here, AC. And it is a segment. There's another radius for the smaller circle. Well, it could be AD. There's even one more. Do you see it? Yes, segment AB. All right, now radius of the larger circle. There's only one. Goes from the center of the circle out to the outermost edge. And that would be AI. All right, interior region of the smaller circle. On the inside of the smaller circle. So you can only look at the inside of that smaller circle. Name a point that's on the inside. There's only one. And it's the center. It's A. All right, how about a point that is in the exterior region of both circles? So outside of both circles, would be H. All right, now here's a tricky one. We've got to think about this. Name a point that is in the exterior of the smaller circle, but on the interior of the larger circle. So outside of the smaller circle, but still inside the bigger circle. Yes, that's G. All right, now chord. And it doesn't specify which circle, so got to find a chord. So we were looking for a segment whose endpoints are on the circle. There's actually two chords up there. One of them is EF. There's another chord. BC is also a chord. But BC has a more specific name because it goes through the center. It is also called the diameter. And the diameter is a chord. It's the longest chord actually in a circle. All right, what's the length of the diameter in the smaller circle? Now the smaller circle, radius is 8. So the diameter, twice that, 16. Okay, diameter of the larger circle. Well, let's see, radius of the larger circle is 8 plus 3, so radius of the larger circle is 11. Double that, 22. All right, I'm going to kind of have to flip back and forth here so we can see these problems down here on the bottom. What kind of arc is arc ED? Notice it's 2 letters, so we want the shortest distance between E and D. So from E to D, is that more than halfway around, exactly halfway around, or less than halfway around? From E to D is less than halfway around. This is a minor arc. And a major arc, we have to go more than halfway around, so we're going to need 3 letters. Let's see. How about if I said E through F to C? E, F to C. That's more than halfway around. B to C is halfway around, so if I go more than that, E to F to C. That's a major arc. Let's see if we can find another one. How about if we went D, C, F? That's not quite halfway around. D, C, B? Sure, that would work. How about even D, C, all the way to E? D through C, all the way around to E. Now comment. D, C, E, and what if I said D, F, E? D through F to stop at E, and D through C to stop at E. These are exactly the same. These two are exactly the same arc. They're just different names for that same arc. All right, how about 2 semicircles? So exactly halfway around. Let's see, I can only use the little circle because I don't have a diameter marked on the big circle. So let's see, I could use the top half, B, D, C. That would be the top half. Bottom half would be B, F, C. Or both of them could be just BC, naming the 2 endpoints of the diameter. If it doesn't matter which half, top half or bottom half, then you could use just BC to name both of those. But if I ask you this on a test or quiz, don't write BC and BC. Name them separately. All right, what's the area of the larger circle? Oh boy. Okay, over here in this box, we have area is pi times radius squared. So for number 16, area is pi times radius squared. What was the radius of the larger circle? Radius of the larger circle, radius was 11. So that area is pi times 11 squared, or 121 pi. You may leave your answers with pi unless we tell you otherwise to use decimal places. So we'll just leave it as 121 pi. And then for number 17, what's the circumference of the smaller circle? Circumference, you may use either 2 pi r or pi times diameter. Either one is acceptable. I'll show you both right now. Radius of the smaller circle, if you look back up there, radius of the smaller circle was 8. So we have 2 pi times 8, and then we could multiply the 2 times 8, and we'll get 16 pi. If you choose pi times diameter, diameter is 2 times 8, 16, and we do get same thing, 16 pi. Okay, let's see. I need a question for today for you to answer in your notes. So here's the question for today. What is the name of this mathematical tool? What's the name of this mathematical tool? It's a protractor. It's a protractor. So please, when you, after you watch the video, go ahead and submit the answer to the question, and you will say the tool that Mrs. Rachel showed was a protractor. Thank you very much. Go do this section 7.1 homework, please.